Hey guys, Mr. Milton here. Today we're going to talk about properties of parallelograms. At the end of this video, you should be able to use the properties of parallelograms to find missing side lengths and angle measures. Okay, so as we talk about parallelograms, I want to remind you that last lesson we talked about classifying quadrilaterals. And so when we talk about parallelograms, remember there are three quadrilaterals that fall into the parallelogram family. Those are rectangles, parallelograms with all right angles, rectangles, rhombuses, or rhombi, parallelograms with four congruent sides, and then squares. They are parallelograms with four congruent sides and four congruent angles, or four right angles. Okay, so when we talk about parallelograms, realize that these figures fall into these same properties. They have these same properties. Okay, so therefore all of these properties you're about to learn today also apply to these quadrilaterals. So the first property we're going to talk about is that opposite sides of parallelograms are congruent. Sorry, I was thinking ahead of myself. Opposite sides of parallelograms are congruent. So what we want to be able to prove is that BC is congruent to AD, and also that AB is congruent to CD. Alright? And so, with any proof, remember we just start off with what we're given, and in this case we're given that ABCD is a parallelogram. So they told us that ABCD is a parallelogram, and that is it. And I'm just going to abbreviate parallelogram with a parallelogram drawing. Okay, and that reason is given. So from there, that means we need to know about parallelograms a little bit so we can build off of this. The fact that ABCD is a parallelogram should help us out because we know that parallelograms have two pairs of parallel sides. Okay, so from this I can say, well, AB is parallel to CD and BC is parallel to AD. And that's just because I know that that's what a definition of parallelogram is. Parallelograms have two pairs of opposite parallel sides. Okay, so I'll use that marking. Mark what I've said. Boom, 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 boom. Okay, great. Now this helps us out because now that we have parallel lines, jumping back to the first semester, we can use all that information from the first semester. Anytime you see parallel lines, you should be automatically thinking same side interior angles, opposite interior or alternate interior angles, and corresponding angles. Those are the things that should jump into your mind as soon as you see parallel lines. And in this case, same side interior angles doesn't help us out too much because if you kind of see the picture that I'm seeing two triangles. If I need to prove that two sides are congruent, I'm probably going to try to prove that our triangles are congruent, and then from there use CPCTC. That's just my thought process in this proof. So I can see parallel lines, I can see alternate interior angles. I can see angle 1 and angle 4 are alternate interior angles. Okay, with A, B, and CD being the parallel lines and AC being the transversal. So I can say that angle 1 is congruent to angle 4. Okay. Alright, so I already marked that they're congruent, and from the same thought process, really, I can say that angle 2 and angle 3 are alternate interior angles, so they should be congruent to each other as well. Okay, I can make another line and say the same thing, but I'll just save space, just like I did with parallel lines. Okay? So now that I see that these two are alternate interior angles as well, I have those congruent. Now if I look at triangle ABC and triangle, let's say CDA, they also share a side. They share the side AC. And so AC is congruent to AC by the reflexive property. So what I end up having between these two triangles is that I can say that triangle ABC is congruent to triangle CDA. I want to make sure that I use the correct markings, right? A has one arc, C has one arc, C has two arcs in this triangle, A has two arcs in that triangle. So that's correct, ABC, CDA. And that's because of angle side angle, ASA. Okay, now that I know that those triangles are congruent, then I can say the corresponding parts are congruent. So BC should be congruent to AD, and also that AB should be congruent to CD. And that is true by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so blast from the past. Don't get too stuck into the proof. The proof shows us that it works, but now from there we can use it knowing that the opposite sides of parallelograms are congruent. Okay, property 2 that we're going to talk about so we can use is that opposite angles of parallelograms are congruent. Okay, and so we can prove that angle N is congruent to angle Q. These are opposite angles. Okay, they don't share a side. And angle P is congruent to angle M. Again, opposite angles. They do not share a side. Alright. So again, all we're given is that it's a parallelogram. And that helps us because now we know that if it's a parallelogram, then this must be true. That's all we know. So, started our statement with the given MNPQ is a parallelogram. Reason given. Okay. So from there, what can we do? Well, parallelogram. What do I know about a parallelogram? I know that it has two pairs of opposite parallel sides. So I know that MN is parallel to PQ. And I also know that NP is parallel to MQ. And that's just because that's what a parallelogram is. Definition of parallelogram. Okay, and I'll make my markings because that way I know both visually and in my proof what I'm doing. The way that we're going to approach this is we're going to be looking at same side interior angles. Okay, now NM and PQ are parallel to each other, and NP in this case will be our transversal. These two angles are going to be same side interior angles. I know that angle N plus angle P should equal 180 degrees. Okay, that's because of the same side interior angles theorem. Okay, and the same way I can say that NP is parallel to MQ and NM is the transversal, right? So I could also say that angle N plus angle M equals 180 degrees, correct? I'm going to keep that in the same note. Okay, so really, in this next step, I said NP, angle N plus angle P is 180, and angle N plus angle M is 180. Well, that means that angle N plus angle P equals angle N plus angle M. Right? Just substitution. Remember, we can substitution anytime that we have two things that are the same. Okay, and so basically, instead of using 180, I'm using n plus p, right? N plus angle n plus angle m equals angle n plus angle p. And then from there, then I can say, well, let's subtract angle n from both sides. If we subtract angle n from both sides, what are we left with? Angle p equals angle m. And that's just subtraction. Okay? And so we only did that with angle p and angle m, but we could also do that with n and q if we wanted to. Okay? To show that opposite angles of parallelograms have to be congruent. Okay? So the two properties you should know, opposite sides of parallelograms are congruent and opposite angles of parallelograms are congruent. Okay? Okay, and then the last property of parallelograms that you need to be familiar with is that the diagonals of parallelograms bisect each other. Given again that ABCD is a parallelogram, important that that's our given step, because that means that as long as it's a parallelogram, if you can prove it, it works for all parallelograms. And then want us to prove that AC and BD bisect each other. Okay. And so in other words, what we need to prove is that BE is congruent to ED, and also that AE is congruent to EC. Okay, so start with the statement ABCD is a parallelogram. That is given. From there, what we'll need to say is the definition of parallelogram. We can say that AB is parallel to CD, and also that BC is parallel to AD. Okay, and that's the definition of parallelogram. Okay, so we'll mark that. Okay. Alright, so since we have those parallel lines, then what we can use, again, anytime we use parallel lines, we should be thinking about those angles. And what I see here is that I have a pair of alternate interior angles. So I can see that angle 2 is congruent to angle 3 by alternate interior angles. I'll just do AIA. Alright, and from the same thought process, we can see that angle 4 is congruent to angle 1. Okay, again, alternate interior angles. Alright. Okay. So now what we're going to do is we see that these two angles, we have these two pairs of congruent angles. Darken those in for us. Alright, and since I want to prove that BE and ED are congruent and AE and EC are congruent, I'm really looking at these two small triangles. I can say that AB is congruent to CD. Okay, we prove that opposite sides are AB is congruent to CD. Opposite sides in parallelograms are congruent. So really this is a definition of parallelogram. We proved that earlier, that it has to be true of parallelograms, so now we can use that. And so now we can say that these two triangles, triangle ABE, should be congruent to triangle CDE, and that's by angle side angle. Okay? And so now the corresponding sides, parts of the triangle, should be congruent. So I can say that BE is congruent to ED, and that AE is congruent to EC because of CPCTC. Okay, so the important part here is that the diagonals of parallelograms bisect each other, and you're able to prove that that has to be true just given the fact that it's a parallelogram. Okay, so now example problems. First one, let's solve for x. It says find the values of the variables in each parallelogram. So, since this is a parallelogram, they told us that we need to know opposite sides are congruent. So, we know that 3x minus 15 should equal 2x plus 3. Opposite sides, they have to be congruent. These two are opposite sides, they have to be congruent. So 3x minus 15 equals 2x plus 3. Just solve now. We have x, add 15 to both sides, equals 18. Okay. Our second part of this, we need to solve for y. We have 2y minus 1 equals x plus 7. Now, just looking at this information alone, we wouldn't be able to solve it, but we do know that x is 18. We just solved for it. So now we have 2y minus 1 equals 18 plus 7, which is 25. Or 2y equals 26, and y equals 13. Okay. Alright, the next problem, we want to solve for x and y again. This is talking about diagonals, and we know that the diagonals of a parallelogram bisect each other. And so what that tells us is that these two segments are congruent to each other, and these two segments are congruent to each other, which essentially sets up our problem. 3y minus 7 equals 2x. Also, x plus 1, plus 1 equals y. Okay? Now you might say, oh, well, we can't solve for it in either equation, but as a system, we will be able to solve it. Okay, y is the same as x plus 1. And so now in the first equation, instead of writing 3y, I'm going to write 3x plus 1 using substitution. Minus 7 equals 2x. So I'll distribute 3x plus 3 minus 7 equals 2x. And then we'll just combine like terms, start solving. 3x minus 4 equals 2x. Subtract 3x. So I'll get negative x equals negative 4, or x equals 4. So x equals 4. And now that we know that x is 4, we can plug it back into this equation, and we'll find that y is 4 plus 1, or 5. Okay? More parallel lines cut off congruent segments on one transversal. Then they cut off congruent segments of every transversal. Okay, and so what that shows us here, we can see that in this transversal here, these segments are congruent. And so that means that these segments of the transversal must be congruent, and these segments of that transversal must be congruent. So pH should be 6.7. Km is talking about this segment from here to here. So it's not 4.2, but 4.2 plus 4.2, which is 8.4. Okay? Alright,